Welcome to the second last episode on the series on factorization, and today we're going to look at how we use factorization in the division of algebraic fractions. So we're going to start off in exactly the same way that we did for multiplication of algebraic fractions, by looking at all the numerators and denominators and seeing what we can factorize. So looking at this first example here, my numerator of the first fraction, I have an x variable there but no x in the second term, so I'm looking at my numbers and the highest common factor is 3. Once I've taken out the HCF of 3, I'm left with x squared, and 27 divided by 3 is 9. In the denominator I have a common factor of 2, and then I'm left with x plus 6 divided by 2 is 3. For the moment, I'm going to leave this as a division sign. We're going to speak about it just now, and I'm simply going to factorize all the way through. So if I look at this, I've got a difference of two things. That's definitely a perfect square. Is x to the power of 4 a perfect square? Well, if we remember perfect squares when we're dealing with powers, if the exponent is an even number, then the whole power is a perfect square. So that is a difference of two squares, which is going to factorize into two brackets. So to find out the square root of x to the power of 4, we're going to have to say 4 divided by 2, because it's a square root, which is going to give us x squared, x squared. The square root of 81 is 9. And then for dots, one gets a plus and one gets a minus. Looking at the denominator, I have a common factor of 6, and that will leave me with x minus 3. So it appears as if everything's been factorized, but always go through, because what can happen sometimes is you factorize into two brackets and then one of the brackets can factorize further. So this is a sum of two squares, and a sum of two squares is not factorizable, so don't fall into that trap. Simple binomial, another sum of two squares. Here's another difference of two squares, so that one's going to be able to go further. So nothing needs to be done here, so we have to remember every time to write down the things that we're not using yet. We are going to use this later, but we need to keep bringing it down from one step to the next, otherwise we lose it. And now we're going to look at this division sign. If we go back to multiplication of fractions, the method that we use is times and tip. I know most people call it tip and times, but I'll show you or remind you again just now why I call it times and tip. So I'm just going to write it underneath here because we're going to be using that technique here as well. So if you think back to multiplication, in multiplication the method we use is cross multiplication or cross cancelling, but that only works for multiplication. It's in the name, cross multiplication. So I'm going to think of the fact that division is the inverse operation of multiplication. So I'm going to use the inverse operation, but then I also have to invert the fraction, which means turn it upside down. So my division sign is going to become a times sign, and that's why I like to name the times first, so that I know the order in which I'm doing things. Change divide into times, and then tip the following fraction. So I don't have to do anything more to this denominator, so I'm going to write it down first, but remember I'm tipping the fraction, so the denominator is now going to be in the numerator. This numerator is coming down to the denominator as I tip it. Remember, that is not factorizable, so I just write it down as it is. And then x squared minus 9 is a difference of two squares, so it's going to become x plus 3, x minus 3. Right, now that I've got everything into a bracket that is not able to be factorized further, I can start to cross multiply because I've converted my division into a multiplication. So now I'm going to look for whole brackets that can cancel with whole brackets. But remember, they have to be identical, and the one has to be in the numerator and the other one in the denominator. So I've got x minus 3, x minus 3. I've got x squared plus 9, x squared plus 9. Do not be tempted to cancel these two. They are identical, but there isn't one in the numerator, one in the denominator. So now let's look at my numbers. 2 goes into 2 once, and 2 goes into 6 3 times. Again, don't be tempted with those 3's because they're both in the numerator. So now if I tidy up what's left over, 3 times 3 is 9. And I've got x plus 3 times another bracket of x plus 3. So because they're exactly the same brackets, I could write them as x plus 3, but even better, I could say I've got x plus 3 all squared, because it's the same bracket times the same bracket. And that's how I've been able to bring that whole expression right down to its simplified form. Right, let's have a look at this one where I've got 3 fractions and only division signs. So again, remember, I am going to be changing my division into multiplication, but at the same time I also need to be looking at all the numerators and denominators to factorize where possible. So looking at this, I've got a quadratic trinomial, and remember, when we're factorizing that, we need to look at this constant term and think of factors of that term that could give me the middle number. So let's think of the factors of 1 times 4. 1 and 4 cannot give me 2. Other factors of 4, 2 times 2, whether I add the 2's or subtract the 2's, I'm not going to get a 2. So this quadratic trinomial, we are unable to factorize it. So we have to leave it exactly as it is. Let's see if the denominator will factorize. I've got a difference. I've got 2 terms. That's a perfect square, 1 times 1. And those are both squared, so that's a perfect square. So factorizing that dots into 2 brackets is going to give me square root of this is simply xy, square root of 1, and I've got a plus sign and a minus sign. So now I'm going to start getting clever and saving myself from doing an extra step. Here we did all the factorization and then we did the times and tip. I'm going to do the times and tip as I go. So I'm going to change this into a times sign, and remember, whenever you do times and tip, the sign you change will invert the very next fraction that comes after it. So this conversion inverse operations is going to change this one. So let's look at this, but remember, when we factorize it now, it's not going to be at the top anymore, it's going to be at the bottom. So x cubed minus 8, I've got a difference, that's a perfect cube, that's a perfect cube, a difference of 2 cubes. So a good way to practice this again, remember, it's going from the top to the bottom. So my first bracket is going to be cube root of that, which is x. I'm going to keep the same sign, and cube root of 8 is 2. For my second bracket, I'm going to square that, x squared. Whatever this sign was, I'm going to have the opposite sign, and to find the value, I'm going to multiply that by that, which gives me 2x. And then my last term is always going to be positive because I'm squaring, and I'm squaring the 2, which will become 4. Right, so that was factorizing a difference of 2 cubes and remembering that I'm tipping the fraction, so it was at the top, it's now at the bottom. The common factor here is x, and I'm left with xy plus x divided by x is 1. Don't forget that term. Again, if there's a division sign before a fraction, you're going to times and tip. So times, that's nothing can be done to it, so I'm simply going to write it down, remembering it was at the top, it's now at the bottom. Common factor of these two is y, and I'm left with xy minus 1. Very long sum, almost going off the page. Right, we need to check through all our brackets, see if any of our brackets can be factorized further. They can't, so this is the fun part where you just start crossing things out. But remember, when we're crossing them out, we're actually saying xy minus 1 goes into itself once, xy minus 1 goes into itself once. So we are doing something mathematical, but we speak in shorthand and we just say cancel, cancel. Right, so same bracket, same bracket. Here I've got this unfactorizable trinomial with the same unfactorizable trinomial. And remember, if it's at the top and it hasn't got a bracket, it's acting as if it's in a bracket because the top is containing it. So that whole bracket can factorize, can cancel with that bracket. Right, there are no brackets of x minus 2, but now let's look at these single values out here. I've got a y, cancels with a y. I've got an x, can cancel with an x. And remember, the reason I'm able to cancel is because everything is being multiplied or divided. And that's why I've created numerators and denominators with multiplication signs in the numerators and the denominators. So when everything is cancelled at the top, don't think you're left with nothing, because remember what I said here. Xy minus 1 goes into itself once. So all of these have gone into themselves once. So because everything's cancelled at the top, we're left with 1. And at the bottom, all 1s except the bracket x minus 2. I can write it in a bracket, but I don't need to anymore because it's not being multiplied by something else. So that would be the simplest form that it's in.